What's up, guys? Hope everybody's doing well. It's been very hot these last couple days, so if you hear my AC kick on, I apologize. We've heard a lot about DeFi in regards to Ethereum, but not so much when it comes to Bitcoin. So when I see these articles come up specifically about possibly changing Bitcoin to allow things like DeFi to be incorporated into the protocol, it definitely piques my interest. And I wanted to share with you guys some of these articles that I found regarding this. This one here is specifically about discrete log contracts and incorporating them into Bitcoin in order to bring things like call them pseudo smart contracts into Bitcoin to allow some of the DeFi items like derivatives and bets, so to speak, to be made using Bitcoin all on chain. So I'm going to quickly go through this opening paragraph here and then just go down into exactly what discrete log contracts are, because there's a lot of details here that I don't want to bore you guys with. But let me just jump into this first part here. DeFi has attracted significant attention over 2019 as hundreds of projects on Ethereum have emerged at the intersection of blockchains and open financial instruments, ranging from collateralized stablecoins to derivatives products. While much more feasible at this point on a smart contracts platform like Ethereum, the notion of decentralized finance does not explicitly exclude Bitcoin from the broader implications of DeFi products on the legacy cryptocurrencies network. Although not expressly DeFi, as they are hybrid instances of blending crypto assets and conventional financial structures, companies like BlockFi already offer borrowing and lending with Bitcoin. And I believe I've already covered BlockFi. They do offer a pretty good rate for you to store your Bitcoin with them. They give you a pretty good interest rate. The issue is that you actually are giving up ownership completely of that Bitcoin. And unless you read the fine print, you might not realize that if you send them your Bitcoin in order to make interest on it, it could take up to 7 days for you to get it back from them if you need to use that Bitcoin. So keep that in mind. What's happening here? Similarly, sidechains may eventually furnish the type of smart contract capabilities similar to Ethereum that can enable more sophisticated financial products built on Bitcoin. However, there are some other intriguing takes on extending Bitcoin's protocol to more advanced financial applications, and specifically, one interesting proposal that has gained traction over the last couple of years is called discrete log contracts. So what exactly are discrete log contracts when it comes to Bitcoin? And I actually do have the PDF here that goes into it. I will link that for you guys. Initially proposed by Thaddeus, I think it's Dreja, of the MIT Digital Currency Initiative, and incidentally, co-author of the original Lightning Network paper, discrete log contracts are a method for minimizing the trust in acquiring data from external sources to the blockchain, popularly referred to as oracles. At a high level, discrete log contracts do not enable Turing-complete smart contracts on Bitcoin. Rather, they hinge on using Schnorr signatures to mask the agreed-upon contract details from the oracle, effectively creating a situation where payouts on publicly known data, i.e., a number, are possible between three parties in the process. The immediate advantages are better privacy and more flexible smart contracts without the trust compromises at the scale of a sidechain. So what it's saying here in this paragraph is mainly, when you have a Turing complete blockchain like Ethereum, it's actually able to, because it stores state, it's able to actually compute on smart contracts, which is why we're able to do these crazy things like maker, compound, creation of a stablecoin DAI. This is much more simple, where it's really just using kind of storage space on the blockchain and signatures in order to mask certain data from some parties, but allow and for them to write to it, but other parties to see it, if that makes any sense. Here's an example. So for example, and within the context of DeFi, Alice and Bob can open a futures contract between each other, speculating on the future price of Bitcoin on a specific date. Using the power of multi-sig outputs, the details of their contract can be masked from the blockchain, with the contract containing the committed funds of both Alice and Bob. So, but it says masked. It's because of they're using multi-sig outputs, they can mask the contract from the public, basically. Subsequently, a third-party oracle publishes signed messages that are incorporated into the contract details as the pivotal data that determines how the funds in the contract should be allocated. And that's without the oracle seeing the details of the contract between Alice and Bob. In the case of Alice and Bob's futures contract, funds committed to the contract would be delivered based on the supplied price of Bitcoin at the expiration of the futures contract. Importantly, the oracle is blind throughout this entire process to both the fact that Alice and Bob are using its price data and about the actual details of the contract. So the oracle, the third party, cannot see the details of the contract between Alice and Bob. And it's still able to write to this contract quote unquote. It is a contract. It's just not Turing complete. So it's able to write to the contract with the Oracle data. So in this case, it would be the data about the price of Bitcoin on a certain date, just as a blind third party, so that Alice and Bob are getting this data without the Oracle being influenced in any sort of way. This prevents the oracle from front-running or manipulating the contract with bad price data. Additionally, the setup precludes the oracle from becoming a decisive party in the agreement between Alice and Bob, i.e. 2 of 3 multisig, and instead enables Alice or Bob to withdraw funds based on the blind signed message that is publicly published by the oracle. The downstream consequences of such a model are that the inherent trust assumptions of oracles connecting blockchains to the outside world, known as the oracle problem, can be reduced to a point where more advanced smart contracts can be run on Bitcoin without making prohibitive trust trade-offs. So because the oracle, in the past, a lot of these oracles were kind of used as an intermediary between the two parties. And with this kind of setup, the oracle can blindly insert the data into it without being, like I said, influenced by the contract data itself. And the way that it's actually achieving this is through Schnorr signatures. And I actually have something here about that. Widely considered the best digital signatures by cryptographers, Schnorr signatures have numerous advantages over other methods. Schnorr signatures were made possible for integration into Bitcoin with segregated witness, and have long been one of the top priorities among Bitcoin developers to replace ECDSA. Schnorr signatures are known for their elegant simplicity and efficiency. The trapdoor function that secures Schnorr signatures is based on specific discrete logarithm problems. Like other trapdoor functions such as prime, factorization, and RSA, these problems are intractable, making them one-way functions. One of the most critical advantages of Schnorr signatures is their support of multi-signatures. In Bitcoin, transaction inputs all require their own signature, leading to an inefficient amount of signatures included in each block. With Schnorr signatures, all these inputs can be aggregated into one signature, saving vast amounts of space in each block. Moreover, Schnorr signatures can increase privacy by incentivizing users to use CoinJoin, the coin mixing technique that was traditionally too inconvenient to use regularly. Schnorr signatures reduce the size of transactions in CoinJoin, lowering the mining fee and making it more viable for wallet services to integrate as a feature. Finally, Schnorr signatures can help augment the capacity of multi-sig transactions. Vastly more complex multi-sig transactions, such as 20 of 100 or 50 of 1,000, are possible with the same digital signature size as a traditional transaction. The consequences of this are more complex smart contract functionality and better network scalability. So by utilizing Schnorr signatures, discrete log contracts are possible, which gives Bitcoin a way to actually do things in a DeFi-like manner, all on layer one, which is actually pretty cool. So I will have a link to this article in the description. Please like the video if you liked it. Please share it. And if you're not a subscriber, please subscribe. I'd love it. That's all I got. Thanks.